bunch of vectors to a real life situation. We have a farmer in Brazil, and he's trying to cross the river to get to his farm. But there is also a current traveling directly east, pushing his boat. As you can see, the blue vector represents the current, and the green vector is where he needs to paddle in order to eventually wind up at the farm. Okay? So we need to find out, in the problem we know this is 40 degrees, that his farm is 40 degrees from the edge of the river. But he needs to go a little bit further than 40 degrees to compensate for the current. So what we need to find out is, first of all, let's find the magnitude. Let's call this R for the rate that he needs to paddle. Okay? We have a triangle situation. So let's use, looks like a law of cosines. So we set it up, R squared is equal to, equal to 7 squared plus 2 squared minus 2, 7 times 2 times the cosine of our angle opposite R, which is also 40. Notice that we have parallel lines. These are alternate interior angles. So we know that that interior angle is 40, so it's cosine of 40 degrees. And we do the math. 49 plus 4, this is still R squared, minus 28 cosine of 40, R squared is equal to 53 minus 28. Cosine of 40 is 0.766. All right. And now we do not subtract 53 minus 28. 28 is a coefficient. It is not a constant. So please, I've seen many of you do this. Do not subtract 28 from 53. We subtract, we multiply this out. 28 times 0.766 is 21.45. This is 53. And we still have R squared waiting patiently on the left side. Do subtraction. We get a difference of 31.55. That's R squared. Take the square root of both sides. And R is equal to 5.62 kilometers per hour. All right? So we can put that in over here on our river. This is 5.62 kilometers per hour. All right, but this is not the whole answer. This is just part of the answer. So let's make a little space up here and put that partial answer up here so we don't lose it. So R is equal to 5.62 kilometers per hour. Now we need to find the direction of that vector. So we're looking for this little green angle in here. Let's call it theta. Okay? Now, once we find theta, we can add it to 40 and find the angle that the farmer will take his boat. This looks like a law of sines. Hopefully you've all guessed that. So let's set it up. Sine of theta over 2 is equal to sine of 40 over 5.62. Let's do the cross products. Well, actually, let's we can isolate sine of theta. Let's multiply both sides by 2, and we get sine of theta is equal to 2 times sine 40, all divided by 5.62. Plug it in your trusty rusty calculator, and you will get sine of theta is equal to 0.22875 And since we need to find the angle, we have to do the inverse sign on our calculator. So theta is equal to inverse sine of 0.22875. Theta, therefore, is equal to, punch it in your calculator, it is indeed 13.2 degrees. Now we have to add it to this 40 that we have over here. So let's add this in here, plus 40, and that will give us our final answer of 53.2 degrees. There we have our direction, and we have our magnitude up here. We can write it on this guy right here. So our angle is 53.2 degrees. Hope that's clear.